Good day and welcome to today's construction class. My name is Oluwatunbi Blessing Olalekan, the founder of Maeklltech. Alright, today we'll be considering the interesting topic displayed on the screen titled auxiliary projection. Right. So for today I'm going to actually be explaining the first aspect of auxiliary projection, all that you need to know and how to actually come up with solutions to some of the problems you might have encountered on this topic titled what? Auxiliary projection. All right. So before we proceed, auxiliary projection. What differentiates auxiliary projection from orthographic projection? You know, in orthographic projection, we either show the three principal views, which is either the front view, the plan, or the end elevation. What am I trying to say? So take a look at this object on the screen. So in orthographic, I will be required to produce this view, or what? Or the plan view. That is it. Either of those three principal views. But in auxiliary, that is not the case. It is slightly different in the sense that auxiliary projection is required when some of the views which we actually need in our orthographic view, we were not able to see them. Or if I am trying to get the true length, the true length of a slopy area. So for example, if I have objects like this, okay, so the true length of this area, I can't actually get that very well in orthographic or isometric. So I can only get that perfectly when I show it in the auxiliary view. Right? And in auxiliary view, we have basically two projections in auxiliary. We have the auxiliary elevation and we have the auxiliary plan view. We have the auxiliary elevation and the auxiliary plan view. So today I will be considering the auxiliary elevation. We'll be considering the auxiliary elevation. Now I am going to actually cite an example on the board, and please calm down, relax, and follow me as I proceed. So let me just check this in. If you are the kind of person that is yet to understand the concept of orthographic projection, you are yet to understand the concept of conversion of view, that is conversion from orthographic to isometric, please, this topic is not for you. That is just the simple truth. If you haven't mastered the art of orthographic projection, neither have you mastered the art of conversion from orthographic to isometric, please, there is no way you can actually understand this topic because it just look like magic. But those who are comfortable with those two topics I mentioned earlier, then you can proceed to auxiliary. What I'm going to explain now, you will understand it perfectly. Alright, so let us paint the first scenario. Today we'll be considering auxiliary elevation. Take note, auxiliary elevation. And the very first example I will be citing right here today is look at this object on the screen. Okay, I have this also. Alright, so these are two views of an object, the front and the plan. And now I was given an arrow in this area like this, same at, let's say, 45 degrees. What does this imply? This implies that I am to show the auxiliary elevation of this object. I have the plan view, I have the front view. How do I show the auxiliary elevation? Now, please relax and listen to me carefully. And listen to me carefully. Now, look at this object. This is the plan of this object. Okay. So, if I am standing right at this corner here, looking at this object from here, I am going to convert this object to isometric now, making this area, because my arrow is from this direction, making this area X as my lowest point. Now, if I'm going to convert this object to isometric drawing, I will be having this. Check. Do you agree with me? This will be the outcome of this subject in isometric, making this area as my what? As my lowest point. So what does that entail? That actually implies that I am standing right here. This is me standing right here. I am standing at this junction here. I am not standing here. Neither am I standing here. I am not standing in this direction. I am not standing in this direction. I am standing right at the center here. Now, if I am standing right here, since my arrow is from here, which means I am what? I am standing right here. If I am standing right here, where will I be seeing? Remember, we are producing what? Auxiliary elevation. So on my elevation, if I am standing right at this junction, I will be seeing this area and what? The whole of this area. Yes or no? Yes. If I am standing here at this junction, I will be seeing what? This area and this area. Alright? Now, take note of this. This shape which we have here, we have the same shape at the back here. Relax. That's why I said, if you don't understand the concept of isometric and conversion from orthographic to isometric, you might find it difficult. But if we are on the same wavelength, if we are on the same projection, then progression, you won't have issue. This same shape I am having here, I am having the same at the back here. Okay, if I tilt this object at 180 degrees, this is what I will be having. Do you agree with me? That's it. So this side here is this side here. So this other side that I said, this same shape that I said we have at this back that we can't see. If I tilt this object, this is it. So that implies that this same shape we're having here and what and at the back. But now in auxiliary, I will first of all show the area I can see on my elevation. So this other area that I can't see at the back, I won't show it. I will show it with hidden line. Now, where are those areas we can't see at the back? Okay, this area now, we have another one at the back here. Can we see it? No. It will be shown with hidden line. This area from here to here like this, we have it at the back. Can we see it? No. Though we might see some aspect, you know I am projecting it on the board. If you project it on paper, you might see some aspect of this area at the back here, but you won't see this place and to maybe somewhere here at the back. That one is very sure. Okay? What I'm referring to is this. So, you see, this area here, this is it at the back, I can't see it. Likewise, this area here, this is it at the back, I can't see it. So those areas we can't see will be shown with hidden views. Now, how do I produce the auxiliary elevation on this object here? How do I produce it? So since my projection is at angle 45 degrees, all I am going to do is I am going to project every corner, every junction I have on my plan at what? At 45 degrees towards the top, towards that direction. So with my T-square and Z-square, do it on your paper. Okay, you can give this in any dimension on your paper and just try it out. So at 45 degrees, at 45 degrees, sorry if my hand is not straight. Okay, at 45 degrees, I project each of those points faintly at what? 45 degrees at what? 45 degrees. Okay, now, lest I forget, if we are moving from, okay, now, in orthographic projection and auxiliary projection, our elevation plane is also known as what? Is also known as the vertical plane. So if any object is crossing my vertical plane to the horizontal plane, which is a plan, it is crossing the what? The XY plane. XY plane. That is it. Now, if I am going auxiliarically, yes, manage my English. Maybe I'm going to write my own dictionary. So if I'm going in the auxiliary plane, then I'm going on the what? On the Y1 and what? X1 plane. Y1 and what? And X1 plane. Now, take note of this. After projecting each of the lines at 145 degrees, I am going to project a perpendicular to my projection. Perpendicular refers to as what? Right angle or what? Or angle 90 degrees. So that implies that since I projected each of these lines at 45 degrees, then I'm going to produce another line at 45 degrees to what? To counter it here. Meaning I'll be having an angle of what? 90 degrees right here. So those of you who are conversant with projection of true shape, in development of solids. So if we did development of a truncated prism or a ten-coated pyramid, we do get what the true shape of the plan. So after projecting all those points, you get the perpendicular. So that is what we are actually doing here. So I'm going to project this perpendicular, ensuring that this line is as right angle to this projector. Now, after doing it, the next thing is this. Take note of this. Remember, we are producing auxiliary elevation. Okay, I'm going to actually cite 2 or 3 examples here. So this is series 1. Okay, I'm going to do series 2 and series 3 on this auxiliary elevation. Okay, that's just it. Now, take note of this. Take note of this. I have projected this, giving me 90 degrees. 90 degree across. Now, looking at this elevation, because we are producing auxiliary elevation. Looking at this elevation, this area here, I will call it Mach 0. I will call it Mach what? Mach 0. Are you following? Now, from 0 to this area, that is an elevation on its own. So I will project it out. I will call it Mach what? Mach 1. So this is Mach 0. This area is what? Mach 1. Are you getting it? Then this area to this area is another elevation. I will call it Mach what? Mach 2. So I am having Mach 0, Mach 1, and Mach 2. Those are the junctions on my on my elevation. So I am going to replicate each of these junctions right here. So let me call this my x1, y1 plane as Mach what? As elevation 0. So with your compass or ruler, measure from this area to this area. That is my Mach what? Mach 1. Let us assume I've measured it, and this is it right here. This is my Mach what? Mach 1. Alright? From 0 to the top, or from 1 to the top, it's your choice. That is what? Mach 2. So from 0, I have my Mach what? So I'm going to take this out. Right here like this. This is my Mach what? Mach 2. So the distance from 0 to 1 here is what? Here to here, which is what? 0 to 1. The distance from 0 to 2 is what? Still 0 to here, to this place, which is what? Here to here, which is 0 to 2. I think that is actually settled like that. Alright? Now, the next procedure is this. So that I don't make mistake, I am going to give letters to each of the junctions I have here. Okay? I am going to call this point capital letter A. I will call this junction capital letter B. I will call this junction capital letter D. ABD. Take note. I will call this other area small letter A. This area small letter B. And this area small letter what? D. Are you following? Now, take note. Take note. You will agree with me that on this pictorial view, I told you we are standing at this junction. And if I convert this object to isometric, this is what I'll be having. Making this area my what? My lowest point. Since that is where we are standing at. Now, you will agree with me that this area on this object is my capital letter A. This is my capital letter B. And this area here, I can see is my capital letter D. You will agree with me. Which means I am having capital letter A at the top and what? At the bottom. Capital letter B at the top and also at the bottom. Then capital letter D at the top and at the bottom. You agree with me that this area, which I am seeing here, that is facing me here, is my what? Is my small letter A, small letter A, small letter B, small letter B, small letter D, and what? Small letter D. Calm down, please. Relax. Just calm down. Calm down. Yeah, I might be too fast. If I am too fast, kindly adjust the play speed of your video so that you can actually watch it at your own pace. Please, you need to calm down. Don't rush things. Calm down. Just calm down, alright? Because auxiliary view is one of the most cheapest topic ever in engineering drawing or technical drawing. Yes, it is cheap like plantain chips. It is easy as ABC, alright? That's just it. You just need to relax, calm down. My capital letter A on my plan, this area of my plan, this is it. You agree with me? This area of my plan, capital letter B, this is it. You agree with me, right? This area of my plan, small letter A, this is it. And it is having what? Up and what? Bottom. This area of my plan, capital small letter B, this is it here. Having what? Up and what? And middle. And my small letter D, it is what? Here to here. Now, you agree with me that this bottom part is Mach what? Mach 0. This area is Mach what? Mach 1. Why the highest part is Mach what? Mach 2. Are you following? Please, kindly follow me. Now, you remember I said earlier on that in auxiliary, we first of all draw what we can see. Now, if I am standing right here, I will be seeing this area and this area. If I'm going to draw this on a normal plane, my XY plane, it is going to be like this. I am saying this area, first of all, isn't it? That is going to be this, right? Which is what? Here, 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 and here. Are you following? Like capital letter A, capital letter A, small letter A, small letter A. That is this place like this. Then I'm saying what? Small letter B, small letter D, small letter D, up to here, small letter B. You agree with me that here and here, this is what we are having, yes or no? That's why I say you need to relax and calm down. And you remember I said, if you don't know how to convert from orthographic to isometric, this topic is not for you. Likewise, if you haven't mastered the concept of orthographic projection very well, this topic is not for you. Because everything I'm doing here will just be as if I am performing magic. Meanwhile, it is not magic, because it is just the continuation of those topics. Alright? Now, this is what we have here and here. We are standing here. I'm saying what? Here and here. What we can see. Now, how do I replicate this right here? That is the issue. How do I replicate this view here and here? Which is this? How do I replicate it here? And that's what I'm going to do now. You agree with me that this area, capital letter A, is starting from what? 0 to what? To 2. And where is the capital letter A? This is the line representing what? Capital letter A. This line is representing capital letter A. And it moves forward from 0 to A to 2. So, from 0 to what? To 2. This 0, 1, and what? And 2. Do you follow? My capital letter A joins small letter A from what? 0 to what? To 2. Also, where is our small letter A? This is my what? Small letter A. It joins capital letter A like that, and it comes all the way downward. Are you following? Now we have this area settled like that. It remains what? This other part. Now, if you look at it, my small letter A joins what? Small letter B at mark what? At mark 2. At mark 2. Small letter A joins small letter B. Where is my small letter B? This is my small letter B at mark 2. So I join that. Take note. Now let us go to the bottom. My small letter A joins what? Small letter D at mark what? Mark 0. Now, this is the bottom, 0. 0. Small letter A joins what? Small letter D. And these are small letter D. So small letter A to small letter D, I join them. Okay? At mark 0, settled. And my small letter D starts from where? 0 to where? To 1. That's the elevation from 0 to what? To 1. So from 0 to 1. That's my small letter D. Now, take note, my small letter D comes to small letter B at mark what? Mark 1. Small letter D to small letter B at mark 1, which is what? Which is this. And my small letter B connects themselves from what? 1 to 2, which is what? This. Are you following? Just calm down and relax. It is not hard. It is cheap, like plantain chips. It is easy as ABC. So, quick one. If you are one of the students that do engineering and technical, please ensure to always eat good food, balanced diet. Yes, ensure to take balanced diet. It is actually going to help you. All right, eat good food. So I did bring you are in one of my physical classes. There are some stuff I'm going to tell you to do, but I can't say that online. Okay, yeah, but all right. So back to what we're actually doing here. Now we've shown those areas so you can see. Now I was saying something earlier on that this same shape we are having here, we have the same at the back, which I represented with this hidden line. And if we turn this object 180 degrees, this area at the back that we can't see, this is it here. But mind you, this is where we are standing at. So this area at the back that we can't see, how do we figure it out? Now calm down. Let us start from mark D. This shape here, we have another one at the back here, but can we see it from here? No, we can't see it. Therefore, and that area we can't see is what? Our what? Capital letter D. This area is the back. This area is the front. If you watch my video on conversion from orthographic to isometric series 1, I explained this concept that all this area are what? Front. Why this area is what? Is back. If you haven't watched it, check the YouTube page. Check my YouTube page and see conversion from orthographic to isometric 1, series 1 or part 1. I explained this concept very well. Okay. This area is my back. So mark D at the back that I can see. This is mark D, capital letter D, and this is it. And it start our distance from here, from 0 to here to 1. So my capital letter D at the back, 0 to 1. You see, I can't see it. So I move on 0 to 1. I can't see it. I know it is there. Are you following? Now, that is what? Settled. That is settled. So the next is this. The next is this. Our so on the front here, it moves from what? Small letter D to what? Small letter B on mark what? On mark 2. You can see this place. At the back, it will what? Capital letter D to capital letter B at mark what? At mark 2. So capital letter D at, sorry, I said mark 2 at mark 1. Sorry, mark 1. This is mark 0, this is mark 1. So capital letter D to capital letter B at mark 1, which we can see. So capital letter B, this capital letter B to capital letter D at mark 1, it will what? ED. You see, it will what? ED. D to B on what? On mark 1. Alright, now our B is from what? 2 to what? To 1 at the front. We can see it. At the back, it is what? Capital letter B. Can we see it? No. So our capital letter B from what? From 1 to what? To 2. And this is what? That is it. Okay. So that is the solution to this problem. That is the solution to what? To that problem right there. Okay, now what I actually draw here, the concluding part of this place, I can't see it. I only see half of it, which is here. I can't see the concluding part there. So then I can't see it, so I will denote it what? And that is what? From what? This area here is what? This capital letter D to what? To small letter D, which is where it is. And this is my capital letter D. Okay, and this is my what? Small letter D, which what? They connect each other. So right here, I am doing it on the board. I will join it with what? Hidden line. So I can't see part of this area at the back. I can't see it. So it will what? It will what? With hidden line. With hidden line. With hidden line. And that is the solution to this very problem on the screen. Okay, that is the solution to that problem on the screen. So that is it. If I am too fast, adjust the video, the play speed to what actually works best for you. You can adjust to maybe 0.5 or 0.75 the play speed, so that you can actually grasp the concept of what I was actually explaining. So I'm going to actually end the part 1 here. So kindly be on the lookout for part 2 of this auxiliary elevation. Once again, my name remains Oluwatumbi Blessing Olalekun, the founder of Maeklltech. Kindly ensure you subscribe to this YouTube channel and also refer it to your friends who might be in need of it. Thank you.